Hey everyone, we're doing a worksheet on similarities, ratios of volume and area. Okay, question number 1. Some cones are mathematically similar. Two of the cones have radii in the ratio 2:3. Write down the ratio of their masses. So we know the formula for ratios of the masses, which is m1. This is question 1. m1 over m2 equals L1 over L2 whole cube. So we need the ratio of the masses, which means we need this side. And do we have the ratios of the length? We do. We do have ratios of the radii, which are 2 and 3. So let's enter the values. 2 over 3 whole cube. So the ratio, final ratio will be 2 cube is 8 and 3 cube is 27. Question number 1. Okay, now question number 2, which is two mathematically similar triangles T and U have two corresponding sides of the length 3 and 12 centimeters. Area of T is 5 centimeters square. Find out the area of U. So if area of T over area of U needs to be the ratio would be length of T over length of U whole square, because the actual formula is A1 over A2 equals L1 over L2 whole square. With area we write whole square over the length ratio. Okay, so what do we have? We have the area for triangle T, which is 5. So I'll write 5 over here over area of triangle U is equals to length of triangle T is 3 and length of corresponding triangle U is 12 whole square. So this becomes 5 over AU equals 9 over 144. Cross multiply and we'll get our answer. 144 times 5 divided by 9, this is giving me 80. So AU will come over here equals to 80 centimeters square. So the answer is 80 centimeters square. Question 3. ABCD is a trapezium. Part A, calculate the area of this trapezium. So area of trapezium is simply half times height, which is 4.7, times sum of opposite sides or parallel sides, which is 11, plus 17. Sum of the parallel sides, 11 and 17. Okay, so this would give me 0.5 times 4.7 times bracket 11 plus 17. This is giving me 65.8 centimeter square. Answer for part A. Part B. A similar trapezium has perpendicular height 9.4. Calculate the area of the trapezium. So we have a similar trapezium whose height is perpendicular height is 9.4. Okay, so now we'll again use the formula A1 over A2 equals L1 over L2 whole square. So area of the first trapezium came out to be 65.8. We have to find area of the second trapezium. So let's leave it as A2 equals to length 1 of the first trapezium is 4.7 and the corresponding length of the second trapezium is 9.4 and whole square. Now I'll solve this. This is 9.4. Okay, now I'll do 65.8 times 9.4 square divided by 4.7 square. I've simply cross multiplied is equals to A2. So let's see what do we get. 65.8 times 9.5 square whole divided by 4.7 square, which is giving me 263.2, which is the correct answer mentioned here, and the unit is centimeters square. Question number 4. A and B are two similar pentagons. The area of A is 126 centimeters square. The area of B is 56 centimeters square. Calculate the value of x. So we know the formula: A1 over A2 equals L1 over L2 whole square. Simply substitute the values. The first area is 126. The second area is 56. The first length is 12. The second corresponding length is x whole square. So cross multiply and I'll get 126 times x square equals 56 times 12 square. X square equals 56 times 12 square over 126, and to make x the subject, take under root on both sides. So now x equals 56, 12 square is 144. Please don't end up cancelling these two, that's incorrect, over 126. Okay, so 56 times 144 divided by 126 under root, answer is 8. So x equals 8, which is the answer given over here. Question 5. Cylinder A is mathematically similar to cylinder B. The height of cylinder A is 10 and the surface area is 440. The surface area of cylinder B is 3960. Calculate the height of the second cylinder. So simply again we will be using this formula: A1 over A2 equals to L1 over L2 whole square. So A1 is 440 and its corresponding length given is 10 whole square, and then A2 is 3960 and we need to find its corresponding length. So cross multiply again, 440 times x square equals 10 square is 100 times 3960. Next make x square the subject, so 100 times 3960 over 440. Now take under root on both sides to get rid of the square on top of x. So this becomes x equals under root 100 times 3960 over 440. So I'm going to enter under root, fraction key in the numerator I'm entering 100 times 3960, in the denominator I'm entering 440. This is giving me 30. So x equals 30 centimeter. Okay. Question 6. Two mathematically similar shapes have area 295. So A1 over A2 equals, the width of the larger shape is 17, so the larger area is the upper area, so we write 17 in the numerator because this is the larger area, over calculate the width of the smaller shape, so let's call this x whole square. So exactly the same method, 295 times x square by cross multiplying equals 17 square times 159.5. So this will become x square equals 295 will go in the denominator. The numerator will be 17 square times 159.5, which is giving me 46095.5. Next take under root of both sides, so x equals answer divided by 295 under root answer again, which is giving me 12.50023. Round this off to 3 significant figures, so 12.5 centimeter is the answer for part 6. Question 6. Question number 7. Marianne sells two sizes of photos. These photos are mathematically similar rectangles. The smaller photo has length 15 centimeter and width 12 centimeter. The larger photo has area 352.8 centimeter square. Calculate the length of the larger photo. Okay, so one of the photos has length 15 and width 12, and the larger photo has, this is the smaller photos. We also have a larger photo which is mathematically similar, although these two barely look similar, but let's assume they're similar. Okay, and its area is 352.8 centimeters square. And what do we need? We need the length of the larger photo. So length is corresponding to 15. Okay, so we need this length. Let's call this x. Okay, so again we'll use the formula a1 over a2 equals L1 over L2 whole square. A1 we can find by simply multiplying 15 with 12, which will give us 180 centimeters square. So 180 over 352.8 equals, the length corresponding to 180 is 15, and the length corresponding to the other one has to be found. Next we know what to do. 180 times x square equals 15 square times 352.8. The numerator becomes 15 square times 352.8, which is 79380 over 180. X square, take under root on both sides, divided by 180 under root answer, which is giving me 21. So x equals 21 centimeter, which is the correct answer. Question 8. The route for the sponsored walk in winter is triangular. The senior students start at A, walk north to B, then walk on a bearing of 110 degrees to C. So they've shown you the bearing, so we don't have to worry about the word bearing in this question. They've already shown us this angle. Okay, then they return to A. Okay, and AB and BC equals 6. So this length is 6, this length is 6 as well. Let me draw a clearer one. So this is their first route, second, and then they come back. Okay, so this is 6 centimeters and this is 6 kilometers. Junior students follow a similar path, but they only walk 4 kilometers north from A. So they walk 4 kilometers till here, then 4 kilometers on a bearing of 110. So this is also 4, before returning to A. So then they return back to A. Okay, senior students walk a total of 18.9. So from that we can subtract 6 and 6 from 18.9 twice. So 18.9 minus 6 gives us 6.9. So this length is 6.9. Calculate the distance walked by junior students, the total distance. Okay, so we need this distance now, this whole distance. Okay, so if somehow I can manage to find this length, then I'll add this, the length in red, with 4 and 4 to get the whole distance walked by the junior students. Now how do I get the length in red? Now keep this in mind that these are similar triangles. So this length the whole length is 6 and this length is 6.9. Similarly, this length is 4 and we can find the length in red. Let's call it x, and this closes the triangle. Okay, so now since these are similar figures, we can apply the formula for ratios of similar figures. So ratios of lengths of similar figures. So that's simply 6 over what's the corresponding length in the next triangle? It's 4, equals to the length in the first triangle 6.9 over the corresponding length in the other similar triangle, which is x. So now you cross multiply, so we get x equals 6.9 times 4 over 6. So we've simply used the ratios of lengths of similar triangles, the ratios of corresponding lengths of the similar triangles. So 6.9 times 4 divided by 6, which gives 4.6. So the length in red is 4.6, and then we add plus 4 to it, which gives us 12.6. This just gives us 4.6. Okay, and 12.6 is the answer. Question 9. Two mathematically similar containers have height 30 and 75 centimeters. The larger container has capacity of 5.5 liters. Capacity is the volume. Calculate the capacity of the smaller container. Give your answer in milliliters. So now we'll use the formula for volume. V1 over V2 equals L1 over L2 whole cube. So it's same as the formula for mass. That's m1 over m2 equals to L1 over L2 whole cube as well. Okay, so the first capacity is 5.5 liters over V2 equals the first length is 30, the second length is 75 whole cube. So similarly, simply solve this. 5.5 times 75 cube over 30 cube. This will give us the volume in liters because this was in liters. Okay, so 5.5 times 75 cube over 30 cube. This is giving, okay, I made a great mistake over here. It said the larger container has the capacity of 5.5. So the larger length is 75. So I should have written 5.5 over here and V1 over here. This was 5.5 and this was V1. So let me quickly fix this. Okay, so here it is fixed. So now when I need to find V1, I'll have to multiply 5.5 with 30 cube over 75 cube. This gives 0.352 liters, and the answer should be in milliliters, so multiply it with 1000. So we'll get 352 milliliters, which is the correct answer. Okay. Question number 10. Toy boat is mathematically similar to a real boat. The length of the real boat is 32 times the length of the toy boat. Okay. So if we have a toy boat and we have a real boat that are both mathematically similar, then the real boat's length is 32 times bigger. So if this length is 1, then this length will be 32. Okay, the fuel tank in the toy boat holds 0.02 liters of diesel. So the capacity or the volume of the smaller boat is 0.02. Uh, Calculate how much liters of diesel the fuel tank of the real boat holds. So over V2 equals L1 is 1 over L2 is 32 whole square, sorry, whole cube. So let's solve this. 0.02 times 32 cube over 1 cube, which is actually 1, equals to V2. So what do we get here? 0.02 times 32 cube over 1 is giving me 655.36 liters. Okay, so the answer in the marking scheme is 655 to 655.4. So any answer between these two is acceptable. So 655.36 is actually the exact answer our calculator is giving us. Okay. Next is question 11. Two cups are mathematically similar. The larger cup has a capacity of 0.5 liters and height 8. So let's write height along with it as well. Whole cube over the smaller cup has a capacity of 0.25. Find the height of the smaller cone x. So simply cross multiply 0.5 times, this becomes x cube, equals 8 cube times 0.25. So now the numerator will become 8 cube times 0.25, which gives us 128 divided by 0.5 equals x cube. Divided by 0.5 actually means multiply by 2. So this becomes 256 equals x cube. Now to get rid of the cube on top of x, take cube root on both sides. So cube root of answer is 6.3496. So x equals 6.3496 centimeters, and rounded off to 3 significant figure, this becomes 6.35 centimeters. Question number 12. Two barrels are mathematically similar. The smaller barrel has height of 8 centimeter and a capacity of 100 liters. Larger barrel has height 90 centimeter and capacity of 160 liters. Work out the value of each. So V1, we're doing question 12. V1 over V2 equals L1 is h over L2 is 90 whole cube. So again cross multiply 100 into 90 cube equals 160 into h cube, and then 100 times 90 cube over 160 equals h cube. Now get rid of the h cube by taking cube root on both sides. Please do not cancel this cube root and cube here. It can't be cancelled like this. Okay, so this can be cancelled. However, you could have cancelled it if this was whole cube. It's not, so you can't. Okay, so I'm going to take cube root, then I'll open the fraction key. In the numerator I'm writing 100 into 90 cube, and in the denominator I'm writing 160. This is giving me 76.9489. So rounded off, this becomes 76.9 centimeters. Okay, question 13. Volumes of two similar cones are 36 pi and 288 pi centimeter cube. So 36 pi over 288 pi V1 over V2 equals base of the smaller cone is 3 centimeters. Calculate the base radius. The base radius of the smaller cone is 3 centimeter. Calculate the base radius of the larger cone. L1 over L2 whole cube. So cross multiply, let's cancel pi and pi first. 36 times L2 whole cube equals 2 cube is 27 times 288. Next I'll make L2 whole cube subject, so 27 times 288 over 36. Now take cube root on both sides, so we'll get L2 equals cube root of this fraction 27 into 288 over 36. So cube root fraction key 27 times 288 divided by 36, which gives 6 centimeters. Answer for question 13. Okay. Question 14. A car 4.4 meter long has a fuel tank which holds 65 liters of fuel when full. So 65 is V1 and the length is, corresponding length is 4.4. This will be whole cube over the fuel tank of a mathematically similar model of a car holds 0.05 liters. Calculate the length of model car in centimeters. So this is in meters, keep that in mind. So our answer of x will also be in meters, and then we'll multiply it with 100. So 65, in fact I'm just going to make x cube the subject here, so this will become 4.4 cube times 0.05 over 65, and then we'll take cube root of this. 4.4 cube times 0.05 over 65. So in the calculator I'm going to turn on the cube root key, then inside I'll turn on the fraction key, then 4.4 cube times 0.05 in the numerator, in the denominator 65. This is giving me x equals 0.40315 and so on centimeters, and sorry, meters. Change it into centimeters, multiply it with 100, so we get 40.3 centimeters rounded off to 3 significant figures, which is the answer given here as well. Okay. Question 15. Two cylinder cans are mathematically similar. The larger can has capacity 1 liter and the smaller can has capacity of 40 milliliter. Now make sure that these units need to be the same. This is 1 liter, so either change this into liters or change this into milliliter. Let me change this into milliliters to multiply it with 1000, so this becomes 1000 milliliters. So the volume ratio, units of the volumes need to be the same, and unit of the lengths need to be the same always. Okay, so let's change this into 1000 milliliters over 440 milliliters equals to calculate the diameter d of the 440 milliliter can. So let's call this d if the diameter of 1 liter can is 12 centimeters. So whole cube. So 1000 times d cube equals 12 cube times 440. So 12 cube times 440 gives me 7603 120 divided with 1000 and take cube root in the end to get value of t. Divide this with 1000 and cube root of answer is giving me 9.1270. So rounded off to 3 significant figures, this becomes 9.13. Question 16. A company sells cereals in boxes which measure 10 by 25 by 35. They make a special edition box which is mathematically similar to the original box. The volume of the special edition box is 15120 centimeter cube. Work out the dimension of this box. Okay, so we have a small a company sells cereal in boxes which measure 10 by 25 by 35. So we have a box of these dimensions. This is a very weird looking box. Okay, so this is, let's say, 10 by 25 by 35. Okay, they make a special edition box which is mathematically similar to this original box. So let's find volume of the original box first. Volume is 10 by 25 by 35. This will give us 250 times 35 is 8750 centimeter cube, and the volume of the other box is 15120. So we have another similar box whose volume is given 15120 and we need the dimension of this new box. So 8750 V1 over V2 15120 equals length of the first box is 10 and length of the corresponding side of the second box is x, and write whole cube over here. So this will give us 8750. Let me make x the subject directly. X equals cube root of 10 cube times 15120 over 8750. So let's see what do we get here. So cube root and then fraction key inside 10 cube times 15120 divided by 8750. This is giving me 12. So corresponding to 10, I am getting 12 over here. Okay, so the first answer here is 12. Next, what you'll do is simply replace 10 by 25. So write 25 over here instead of 10. So we'll get 25 cube. 25 cube and do the same. Let's see what do we get. In my calculator, I'm simply replacing 10 with 25. Cube. This is giving me 30, yes, which is the answer. So this side becomes 30, and in the last step we'll replace 30 with 35. So here I'll write 35 cube now. So this is 35 cube. So in the calculator, I'm again replacing 25 cube with 35 cube. Okay, I've messed it up. No, here it is. 35 cube. This is giving me 42. Yes, the final answer is 42. So this length is 42. So the dimensions of the new box are 12, 30 and 42. Question 17. A cone with radius x and height a y has volume w. Okay, so we have a cone whose radius is x, whose vertical height is y, and its volume is w. Okay. A similar cone with both radius and height 3 times larger. So we have a similar cone, this will be 3x and the height will be 3y. Find in terms of W the volume of a similar cone with both radius and height 3 times larger. So this would simply be if this let's use the formula V1 over V2 equals L1 over L2 whole cube. So this is part 1. Okay, so we simply know that let's say, in fact we're given that the volume of the first cone is W. We need the volume of the second cone, and the bigger cone is 3 times bigger. So if this length is 1, then this length will be 3 times of that. So let's call this 1 over 3 whole cube. You could have also written x over 3x and then cancelled out x. Okay, so we need to make v2 the subject. So v2 equals 3 cube times w, which is 27w, which is the answer for part 1. Okay. Part 2. Okay, let me clear this for part 2. Okay, a cone of radius 2x and height y. So we have, again we had a cone with radius x and height y. So this is x, this is y, and its volume was w. Now we have another cone whose radius is 2x and height is still y. So which means these are not similar cones now, because if these were similar cones, the height should have increased by 2y as well. Should have increased to 2y as well. Since the radius is increasing twice, the height should have also increased twice if these were similar cones, which means they're not similar cones. So now we can't use that formula v1 over v2 equals to L1 over L2 whole cube, because that only applies on similar figures. These are not similar anymore. So now we'll use v1 over v2 equals, what's the actual formula for volume of the cone? That is 1 by 3 times pi r square h. Okay, and and similarly for the second one, it will be 1 over 3 times pi times r square h, and v1 is w. So this is w. Okay, so 1 over 3 gets cancelled, pi and pi gets cancelled, y and y gets cancelled. So we have w over v2 equals x square over, open the denominator, we get 4x square. So cancel out x square and x square, we're left with 1 over 4. So now to make v2 the subject, we get 4w over here. So again I'm repeating, these two cones are not similar now. So we can't use v1 over v2 equals to L1 over L2 whole cube. We can instead use the actual formula for the volume of a cone. In fact, this formula should have been given in the question as well. Yes, the formula is actually given. I did not type it by mistake. Okay, question 18. A company makes solid chocolate eggs and their shapes are mathematically similar. The eggs have height 2 centimeter and 6 centimeter. The mass of the smaller egg is 4 grams. Calculate the mass of the larger egg. So again we'll use the formula m1 over m2 equals L1 over L2 whole cube. So mass of the smaller egg is 4. We need mass of the bigger egg. Let's call it x equals L1 is smaller. Length is 2. The larger length is 6 whole cube. So this becomes 4 over x equals 8 over 6 cube is what? 216. Now simply cross multiply x equals 4 into 216 over 8. 108 is the answer. Question number 19. Part A. In the diagram, PQ is parallel to BC. APB and AQC are straight lines. PQ is 8, BC is 10 and AB is 9 centimeter. Calculate PB. Okay, so we need the length P to be. This is needed. Okay, we're doing part A. Okay, and what do we know? We have AB is 9. So this whole length is 9. This I've used. B to C is 10. So this length is 10. And then PQ is 8. This length is 8. And we need PB. So we can use similar triangles. We can say that this triangle APQ will be, this is A, similar to this whole triangle which is ABC. And why are they similar? Because all their angles are equal. Why are they equal? Because this angle and this angle makes corresponding angles because of these parallel lines. So these two angles are equal, and then this angle is again corresponding to this angle. So these two angles are the same, and the third angle A is automatically the same, and also it's the shade angle between the two triangles. So this angle will be equals to this angle. So these two triangles are similar. So now if we don't know AP, but we know this is 9, we know this is 8, and we know this is 10. So applying ratios of similar triangles, I can write AP over 9 equals 8 over 10. This will give me AP, which is 8 times 9 divided by 10, which is 7.2. AP is 7.2. So PB will simply be 9 minus 7.2, which gives 1.8 centimeters as answer. Okay. Part B. Two glasses which are mathematically similar. The larger glass has a capacity of 0.5 liters and the smaller glass has capacity of 0.25 liters. So V1 over V2 equals L1 over L2 whole cube. Height of the larger glass is 13, so L1 is 13. Calculate the height of the smaller glass, let's call it X. So this becomes 0.5 over 0.25 equals 13 cube is 2197 over x cube. Now we'll make x cube the subject. In fact, let's make x the subject by taking cube root in the end. Okay, so by cross multiplying, we'll multiply 8197 with 0.25 and divided by 0.5. So cube root, and then I'll turn on the fraction key. Then in the numerator I'm writing 8197 times 0.25 divided by 0.5. This is giving me 10.3, which is the answer. So x equals 10.3 centimeters. Question number 20. Part A, triangles CBA and CED are similar. Again, let's discuss why are they similar, because this angle and this angle is corresponding, this angle and this angle is corresponding, and the third angle is automatically equal, and also it's the shared angle between the two triangles, between CBA and CED. So even if this wasn't told to us, we should have known this on our own. Okay, so AB is parallel to DE. AB equals 9, BE is 4.8, EC is 6, and ED is K. Work out the value of K. So again, I'm using the ratios of similar sides. So for part A, it'll be K over 9 equals to 6 over the complete length, which is 6 plus 4.8, which is 10.8. So now cross multiply, K will be 6 times 9 over 10.8, which gives us 5. So K equals 5, which is the answer here. Okay. Then we have part B, which is two mathematically similar vases are such that vase A has the height 20 and volume 1500. I'm using the formula V1 over V2. Do we have V2 here? Yes, we have volume of vase B equals to L1, which is 20, over L2, height of vase B, which we have to find, whole cube. I've used the formula V1 over V2 is equals to L1 over L2 whole cube. Now we've done this plenty of times before, so 1500 times 2592 equals to, this becomes 8000 over x cube. Cross multiply, make x the subject, so and then we'll have to take cube root of 8000 times 2592 over 1500, which gives 24. Next question is, the lines AB and CDE are parallel. AD and CB intersect at X, and then we're given certain lengths. Complete the following statement. Triangle ABX is dash to triangle CDX. So notice this angle and this angle is alternate. Secondly, this angle and this angle is also alternate angles, so they're equal. And thirdly, this angle and this angle is equal because of vertically opposite angles. So since all three angles of these two triangles are equal, which means these two triangles are similar triangles. So answer here is simply similar. Okay, part 2, which is calculate the length AX. So I know that from part 1 I know I'm doing part 2 here. I know ABX is similar to DCX. Now I can use the ratios. AB divided by, this is AB divided by DC, equals BX divided by CX equals AX over DX. So AB is 9 over DC is 6 equals BX, we don't know, over CX we don't know, so let's just skip this, equals to AX is has to be found and DX is 3. So simply cross multiply and we get 9 times 3 over 6, which gives 4.5. So AX equals 4.5 centimeter, which is the right answer. Okay. Part 3, the area of DCX is 6. So area of this is 6 centimeter square. Calculate the area of ABX. So we need this area. So let's use A1 over A2 is equals to L1 over L2 whole square. Okay. So for part 3, A1 is 6 over A2 we need to find equals L1 is, I know this is 6, so let's use 6 over this is 9, we have to use the corresponding length, so whole square. Now open this becomes A2, I'm going to cross multiply 6 times 81 over 36. 6 times 81 divided by 36, this gives us 13.5. Okay, this was part 3. Part 4, angle ABX, BX is X, angle ABX is Y. Find angle AXB and angle XDE in terms of X and Y. Okay, so let's find AXB first. So AXB is this angle. We need to find this angle in terms of X and Y. So this would simply be for part 4, angle AXB is simply 180 minus X minus Y. Okay, and next we have to find angle XDE. So this angle. So we've already established that this is X, so that angle will be 180 minus X. So XDE angle, this is the sign for angle, equals to 180 minus X simply. Next question, the diagram shows two triangles ACB and PBQ. This angle equals to this angle, blah 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 blah, and complete the following statement. Triangle ACB is dashed to triangle APQ. Now notice in these two triangles, this angle is equals to this angle and this angle is equals to this angle, which means their third angle would automatically be equal, because when two angles in two triangles are equal, that means their third angle is also equal. Alright, so that means these are similar triangles since all angles are equal. So you simply write similar over here. Okay. Part 2, calculate the length PQ. So from part 1, we know that ACB is similar to APQ. Now just like in last part, we'll establish ratios, which is AC over AP equals CB over PQ equals AB over AQ. So let's enter whatever we have. Do we have AC? No. Do we have AP? No. So do we have CB now? Yes, CB is 3.6 over PQ we need to find equals AB is 4 and AQ is 3. So PQ is simply 3 times 3.6 divided by 4, which gives 2.7 centimeters, which is the answer. Part 3, so this came out to be 2.7. Okay. Area of triangle ACB is 5.6. This is 5.6 centimeters square. Find the area of triangle APQ. So I'm going to use A1 over A2 equals to L1 over L2 whole square. So let's use this ratio. 4 corresponds to this 3. So 4 over 3 whole square. We could have also used 3.6 and 2.7. That would also give the same answer. Okay, so whole square. So A2 will be 5.6 times 9 over 16. This gives 3.15, which is the answer, centimeter square. Question 23a. The diagram shows two jugs that are mathematically similar. Find the value of x. So that's simply, we're doing part A. 25 over corresponding side is 15 equals x over corresponding side is 7.2. So we've equated the ratios of the corresponding lengths because we're allowed to do that in similar triangles. Okay, so 25 times 7.2 divided by 15, this gives 12. So x equals 12 centimeter. And you can also reciprocate both these fractions. Take reciprocal of both these fractions and you'll still get the same answers. Okay, part B. Two glasses that are mathematically similar. The height of the larger glass is 16. So V1 over V2 equals to L1 over L2 whole cube. And volume is 375 over the second volume is 192, and height of the smaller glass is y. Find the value of y. So again y cube will be equals to, I'll take under root here and get rid of the cube, that will be 16 cube, which gives 16 cube is 4096 times 192 over 375 times 192 over 375, cube root of answer gives 12.8 centimeters. Next question. The diagram shows two mathematically similar containers. The larger container has a base with diameter 9 and height 20. The smaller container has a base with diameter d and height 10. Find the value of d. So we'll simply equate the corresponding lengths of equate the ratios of corresponding lengths of the similar figures. So 20 divided by 10 equals 9 divided by d. So d will come out to be 90 over 20, which is 4.5 centimeters. Okay. And then part B, which is the larger container has a capacity of 1600 ml. Keep this unit in mind. Calculate the capacity of the smaller container. So this will be V2 equals, use any two corresponding lengths. So let's use 20 over 10 whole cube. We could have also used 9 and 4.5, 9 over 4.5 whole cube. Okay, so this would give 1600 over V2 equals 8000 over 1000, which simply gives V2 equals 200 the unit was ml. Keep that in mind. ml. Question 25. Two bottles and the labels are mathematically similar. The smaller bottle contains 0.512 liters of water and has a label with area 96 centimeters square. The larger bottle contains 1 liter of water. Calculate the area of the larger label. Okay, so this is a relatively trickier question. So we know V1 is 0.512 and A1 is 96 centimeter square. Okay, the larger bottle contains, so V2 is 1 liter. This is also in liters. And A2, we are not given any information about A2. Calculate the area of area of the larger label, so we need A2. So what do we do now? We don't have any formula that connects V1 over V2 with A1 over A2. We know V1 over V2 equals L1 over L2 whole cube. So let's work on this first. So 0.512 over 1 equals to L1 over L2 whole cube. Let's get rid of the cube. So we'll have to take cube root on both sides. So this will become 0.12 over 1 whole cube root. This will give us L1 over L2. So let's see what our calculator gives. Cube root fraction key on 0.512 over 1. This gives 0.8. So L1 over L2 is simply 0.8. Okay, so now I'll use the formula A1 over A2 equals L1 over L2 whole cube. So A1 over A2 equals L1 over L2 whole cube. A1 was 96. Yes, 96 over A2 we need to find equals to L1 over L2. We already know that is 0.8 whole square. So 0.8 square and then divide this with 96, which gives us 150. So A2 equals 150. Okay, there's also another quicker way of doing this is, if you notice that V1 over V2 equals L1 over L2 whole cube and A1 over A2 equals L1 over L2 whole square. So L1 over L2 is common in both of these. So if I want to relate the formula for volume and formula for area, so what we can do is take cube root over here. This becomes L1 over L2, and here take under root over here, square root equals L1 over L2, which means now we can equate cube root of V1 over V2 is equals to square root of A1 over A2. If you can remember this formula, and this is a very handy formula, try to keep this in mind, and let's use this now. So cube root of 0.512 over 1 equals to square root of the first area was 96 over, we need the second area. Alright, so let's find the we can solve this first. Cube root of 0.512 divided by 1, which is simply 0.8. So this becomes 0.8 equals to square root of 96 over A2. First we need to get rid of the square root, so take square on both sides. So this becomes 0.8 square, which gives us 0.64 equals to the square root, and square gets cancelled, so we're left with 96 over A2. Now cross multiply and you will get the same value, 150. So if you can remember this formula, then you can do the same question with relatively lesser number of steps. Okay, question 26. Two cones are mathematically similar. The total surface area of smaller cone is 80. So A1 is 80 and A2 is 180 centimeter square. V1 is 168 and we need V2. So again I'm going to use the same formula we just established. V1 over V2 cube root equals to A1 over A2 square root. So substitute values. 168 over V2 cube root equals to 80 over 180 square root. So we can solve this side first. So under root fraction key 80 over 180. This is giving me 2 over 3. So I'm going to write 2 over 3 over here equals cube root of 168 over V2. Now get rid of the cube root by taking cube on both sides. So we get 168 over V2 equals 8 over 27. Now cross multiply and get value of V2, which is 168 times 27 divided by 8, which gives 567 centimeter cube. This was question 26. Question 27. Two mathematically similar solid metal prisms are such that the volume of the smaller one is 648, the volume of the larger one is 2187, the area of the cross section of the smaller one is 36, and find the area of cross section of the larger prism. So I'm just going to make the formula. You will solve this on your own. 648 is V1 over 2187 is V2. We take cube root over here equals to square root of A1 over A2, which is 36 over A2. Solve this yourself to get the value of A2. Never mind, I'll just solve it. Okay, so solving this first. Cube root fraction key 648 divided by 2187, which gives 2 over 3. Next we'll be taking square of 2 over 3, so that this becomes 36 over A2, and then make A2 the subject by multiplying 36 by 9 over 4. 36 times 9 divided by 4 gives us 81, which is thankfully the answer. Okay, centimeters square. Question 28. Two containers mathematically similar. The surface area of the larger container is 226. Surface area of the smaller container is 94. So again, square root of the areas equals to cube root of volume of the larger container is 680. Find the volume of the smaller container. So solve this yourself and you should get this answer. V2 equals to 182 centimeter cube. Okay, so I'm getting V2 equals 182.4055, and rounded off to 3 significant figures, this becomes 182 centimeter cube. Next question. Two mathematically similar solids have volume blah blah. Surface area of the smaller one is 180. Calculate the area of the larger solid. So simply again 180 over 360 cube root equals to square root of 180 over A2. Solve this and you should get 286 centimeters square. Again we'll get an unrounded off answer, which would be 285.7321 rounded off to 286 centimeters square. Question 30 is exactly the same. I'm not going to do it. Let's go to question 31. Okay, so question 31 says a solid cone has base radius 4 centimeters square and height 10 centimeters square. 10 sorry, base radius 4 centimeter and height 10 centimeter. A mathematically similar cone is removed from the top as shown in the diagram. The volume of the cone that is removed is 1 by 8 of the volume of the original cone, which means that if this 1 by 8 volume means that if volume of the smaller cone is 1, then volume of the bigger cone is 8. Okay, so this is actually V1 over V2, not L1 over L2. This is V1 over V2. Okay, explain why the cone that is removed has radius 2 centimeter and height 5 centimeter. Okay, so uh, this length is 4, right, and this length is 10. So they're asking sorry, not this length, this length is 4 and this height is 10. Explain why the cone which is removed has radius 2, this should be 2 and this should be 5. Okay, so we know V1 over V2 already, and we know this is equals to L1 over L2 whole cube. So V1 over V2 is 1 over 8 from here. Alright, whatever the value is, we don't care, whatever the original value of V1 and V2 is. We know that their ratio is 1 by 8. So whatever their original values are, when we simplify them, we will get 1 over 8 equals to L1 over L2. So for the smaller, let's say we have to find the smaller radius over the bigger radius is 4 whole cube. Now solve this and you should get r equals 2. Let's see, this is 1 over 8 equals r cube over 4 cube is 64. Now 64 divided by 8 is 8. 8 equals r cube and r equals 2. Hence we've shown that the radius is 2 centimeter. Similarly, now change this with the height. So let's call this height and this would be 10. We're doing 31 part A. Okay, so now this will become 1 over 8 equals h cube divided by 1000. So 1000 divided by 8 and then cube root of answer, we get 5, which we were supposed to show. So this gives height is equals to 5. Okay, part B now. Calculate the volume of the remaining solid. So, and the volume of the cone is 1 over 3 pi r square h. We're given the formula, we need volume of the remaining solid. So, which means we need to subtract volume of both the cones. Volume of the bigger cone is 1 over 3 pi r square h, and volume of the smaller cone is 1 over 3 pi r square h. Directly enter this in your calculator and see what you get. So I've entered the whole expression in the calculator just like this, and I'm getting 146.6076 rounded off to 3 significant figures. This becomes 147, which is the volume of this remaining solid. Next question, thankfully the last question of this worksheet, which is question 32. The diagram shows a cone with radius 1.75 and height 6. The cone contains salt to a depth of 4.5, which is shown in the next figure. If this is 4.5, that means that this height would be 6 minus 4.5, which is 1.5 centimeters. Okay, we might be using this later. The top layer of the salt forms a circle that is parallel to the base of the cone, which means that the smaller cone and the whole cone would be similar. Show that the volume of the salt inside the cone is 18.9 centimeter cube. Okay, so show that the volume of the salt inside the cone is 18.9 centimeter cube, correct to 1 decimal place. Okay, so we'll be using similar figures. So let me just draw this smaller cube, sorry, the smaller cone over here. So this is 1.5 and we don't know the radius. It's a very weird looking cone. Okay, so we don't know this radius. Okay, so now they're asking us to establish that the volume of the salt here is 18.9 centimeter cube. So to find the volume of this region, we simply need to subtract the whole cone's volume and the smaller cone's volume. But the problem here is now that we don't have the radius in red here. I need this radius here first so that I can find the volume of the smaller cone. Okay, so let's find the radius first. For that, I'll use the ratios of corresponding lengths of a similar triangle. So we know that this length is 6. So I'll write 6 over 1.5. So for part A, I'm first going to do 6 over 1.5 should be equals to 1.75 over the radius. So 1.75 over radius of the smaller cone. Let's see what we get here. Radius would come out to be 1.75 times 1.5 divided by 6, which gives 0.4375 centimeter. Now I'll simply subtract the radius of the volume of both the cones. So the volume of the bigger cone is 1 by 3 pi, this is 3 pi radius square h minus 1 over 3 pi radius square h. I will enter this whole statement in my calculator and I'm getting 18.9415. So this should be rounded off to 18.9 centimeter cube. So this is answer for part A. Part B. The salt is removed from a cone at a constant rate of 200 millimeter cube per second. So we're getting 200 millimeter cube per second. So what is given here? This is volume over time, right? So the salt is removed from the cone at a rate of 200 millimeter cube per second. Calculate the time taken for the cone to be completely emptied. Give your answer in seconds, correct to the nearest second. Alright, so we're given that 200 millimeter cube of salt is emptied in 1 second. So calculate the time taken for the cone to be completely emptied. So from the previous part we got the volume of salt to be 18.94. I'll be using unrounded off answer. So preferably I should use 18.9416 till 4 decimal place. Centimeter cube. I need to change this into millimeter cube. So for that, centimeter to millimeter is into 10. So I'll do that thrice because of cube. Into 10 into 10 into 10. So this is giving me 18941.6 millimeter cube. So I will write 18941.6 millimeter cube in how many seconds? X. So simply cross multiply, ignore the all the units. So 200 times x equals 1 times this 18941.6. So x will be this answer divided by 200, which gives 94.707 seconds, and the question said give your answer correct to the nearest second. So this becomes 95 seconds, which is also the answer given in the marking scheme. So this was all about similarities. I'll see you next time.